Hello all. All along we were trying to set the context for the subject petroleum refining. That is, we try to understand more about the Indian oil and gas industry, the Indian petroleum refining industry, and then we try to know more about how the raw material for the petroleum and petrochemical industry, that is crude oil and natural gas, they are explored, drilled and produced. Then in the last episode, we tried to know more about the petroleum products and their specifications. Now, today we are getting into the subject of the very first activity of primary processing. So, primary processing, that is what we are going to understand in length. So, in this particular episode, we will try to know more about the definition of refinery, why refining, and what are the major functions in a refinery and the steps involved in the primary processing activity. Okay, now we will start from the basics. What is a refinery? A refinery is a processing plant where crude oil is separated into various petroleum products. So, as we understand, crude oil is a mixture of 500 plus hydrocarbons, and this crude oil need to be separated using different processes in different processes. That is what happening in a petroleum refinery, and this is a classic example of a continuous process unit. So, 24/7 365 days a year. So, a refinery would run for almost 3 to 5 years, so until the major turnaround maintenance happens. That is what a refinery. And why at all we need to do the refining? So, we all hail crude oil as black gold. So, though crude oil is very precious and considered as black gold, it is not going to be useful either as a fuel or a lubricant, because crude oil is a mixture of several hydrocarbons. It is difficult to handle them. It is difficult to handle crude oil for any purpose, and it also has got lot of impurities. And this crude oil need to be separated into various fractions based on the boiling range, and finally we have to obtain fuels, lubricants and raw materials for petrochemical products, and that is what going to happen in a petroleum refinery. There are several refineries across the globe, but each refinery is having a different kind of configuration. What does it mean? A refinery can have the primary processing unit and a number of secondary processing unit. So, each process unit has got a set of objectives, and this process unit in the refinery and their capacities are determined by primarily the products demand, product prices, product specifications and crude oil characteristics. For example, an imported crude from Middle East cannot be processed in all the refineries. Similarly, an indigenous crude cannot be processed in all the refineries. Each refinery is built to process a set of particular characteristics of crude oil. So, if at all that particular crude is not available, they will try to blend different kind of crude oils and finally process it. So, that is where the configuration is going to change based on the crude oil characteristics. Now, we will try to understand the different types of refineries. Number one is known as a topping refinery. A topping refinery is the simplest configuration where you have the primary processing unit which will have a atmospheric distillation unit, that is all. So, the crude oil is sent into the atmospheric distillation unit and you get all the products, and the residue is sold as fuel oil. So, this topping refinery is very much suitable for a sweet crude which will not have any sulfur bearing components or any other impurities, and the residue can be directly be sold as the fuel oil. So, there are few refineries across the globe where we have the topping refineries. So, this is possible only when you have the simplest form of crude oil. But whenever you have a crude oil which has got a sulfur bearing compounds, or the crude oil is highly viscous and heavy, then we need to have a complex setup. A complex refinery will have multiple units, and again the number of units will vary depending on the crude oil characteristics as well as I said earlier the product demand, product price, etc. A low complex refinery has a lower and a less value adding units, whereas a highly complex unit will have more number of units and most of the units will be adding value for the products. And this complexity of a refinery can be found using a formula, and this is known as Nelson's complexity factor. So, each refinery has got a complexity factor, and by knowing the number you will come to know which refinery is more complex than the other refinery. And another way the refineries are classified is fuel based refinery and a lube based refinery. Obviously, every refinery will be producing fuel products. These fuels may start with the LPG, gasoline, diesel, kerosene, etc. But there are certain refineries which can also produce lube based oils or lubricants. So, these refineries are lube based refinery or lube refinery, and to have this lube processing unit you are supposed to procure the specific crude having certain properties. So, even in India we have 23 refineries, all the refineries are not producing lubricants. There are very few refineries who produce the lubricants. So, on this way the refineries can be classified into a fuel refinery and a lube refinery. Now, let us get into the major functions in a refinery. What are the major functions? Number 1, primary processing. This is where the crude oil is split into major products starting with heavy naphtha, kerosene, diesel and residue oil. Then there are secondary units which are primarily meant to meet the quality specifications. Then the third set of units which are primarily meant for environmental specifications, and there are units where you will be converting the residual products into valuable products. You are trying to convert low value products into high value products, and finally you will have finishing and blending operations. So, let us try to understand little more about these functions. The primary separation. The primary separation, this is happening in a atmospheric distillation unit. So, here crude oil is heated and sent to a distillation column, and inside the distillation column the different kind of products are separated based on their boiling point ranges. Products from the primary separation stage would be LPG, naphtha, kerosene, diesel and the residue. And now let us try to understand more about the primary processing, how it is happening step by step process. The very first step is the crude oil receipt and storage. For every refinery, the crude oil is either received through pipelines or through tankers. So, most of the time the tanker will come and unload the crude oil parcel in the nearby port, and from there it will be received through pipeline. There are multiple crude tanks which are known as mandatory tanks, and these tanks will be feeding to the refinery, and the multiple tanks will have multiple functions. For example, one tank may be receiving the crude oil from the port from the tanker, the another tank may be feeding to the process unit, and there will be blending operations happening from other tanks, and certain tanks will be doing the water removal process. So, after receipt and after measuring by using the gauging method, we will come to know how much crude oil we have received, and what is the water content inside the crude tank, and what will be the temperature, because the temperature is needed to figure out how much quantum in metric tons we have received, because the measurement of the tank quantity will be measured in depth, and the depth will be converted into volume, and finally only when you know this specific gravity you will be able to figure out how much mass you have received it. And we will also be taking the sample in the crude oil tank, and obviously the crude oil would be heated inside the process unit before sent into the distillation column, and the temperature heated would be 350 to 370 degree centigrade. When crude oil is heated to such a high temperature, if at all if water is present, that will be converted into steam, and the volumetric expansion of steam would be collapsing the internals of the distillation column. So, for this reason the water should be thoroughly removed from the crude oil before sending into the process plants. So, how do we do that? After receipt from the tanker, then the crude oil is allowed to be settled. So, due to the density difference, water settles down, and by opening the drain wall, the entire water will be drained to the sewer pit, and finally the water free oil will be sent to the processing unit. Now, this crude oil will have some presence of salt, because crude oil from oil field may have 1% of saline water and organic salt, and if at all if this salt is allowed to be go along with the crude oil, it is going to cause lot of damages. So, there are several salts, and specifically magnesium chloride, it will tend to hydrolyze. The magnesium chloride would tend to get hydrolyzed above 120 degrees centigrade, and during this hydrolysis process hydrochloric acid is formed, and it can corrode the overhead of the distillation column as well as the condenser in the top portion of the distillation column. So, it is very much essential that the salt present in the crude oil should be removed. How can we do that? From the tank, the crude oil is pumped into the process unit, and it passes through a series of exchanges. Why? Because the crude oil would be heated to around 350 to 370 degrees centigrade in a furnace before sending into the distillation column. To raise the temperature from atmospheric temperature, ambient temperature to 350 degrees centigrade, you need to burn lot of fuel. In order to reduce the load for the furnace, now we are trying to preheat the crude oil in a set of heat exchangers known as preheat train. And where do we get the heat from? The heat is obtained from the products from the process unit before going to storage. They exchange heat with the crude oil, and in this process the crude oil gets preheated, and the products lose their temperature so that they can be safely stored. This is the preheating stage. After preheating, then we have to remove the salt. So, already we have discussed what are the ill effects of salt and how this salt need to be the salt are detrimental for the process operation. The salt removal or desalting can happen in an equipment known as desalter. The desalter is nothing but a horizontal cylindrical equipment, and there are provisions where high voltage electrostatic grids are there. So, here controlled quantity of water is added in the before desalter through a mixing valve, and the water is thoroughly mixed up in the crude oil, and finally with the help of the electrostatic grid the water particles get coagulated, and then finally it will get settled down, and it will be continuously withdrawn from the desalter. The salt free crude will move on to the next stage. As we discussed earlier, the temperature of the crude oil need to be increased to 350 to 370 degrees centigrade. So, only at this particular temperature all the products will effectively get separated, and here this is happening in a place known as fired heater or a furnace, and the fired heater of this particular unit will be huge in capacity, and this fired heater will be having provision to burn the fuel oil generated from the refinery itself. So, the internal fuel oil is consumed as a fuel for the furnace. After getting heated, this oil is entering to the distillation column. The primary separation of crude oil occurs in atmospheric distillation column. The reason why we call this as atmospheric distillation column is the column operates nearly at atmospheric pressure, and there are in other stages the columns may have operate at either at a high pressure or vacuum. So, this particular column operates at atmospheric pressure, and hence it is known as atmospheric distillation. As the crude oil hot vapors enter into the distillation column, the hot vapors start going up through the trays of the column, and as and when the vapors get condensed, then the condensate comes back to the bottom of the column. So, when this vapor liquid traffic equilibrium is reached, once the steady state is reached, so then the different kind of products can be withdrawn from each tray. So, that is heavy naphtha, kerosene, diesel, etc., can be taken from the different sections of the distillation column. The condensed liquid comes down from the top of the column, and as the steady state is reaching, the product separation happens at different levels. Products like heavy naphtha, kerosene, diesel are separated on a continuous basis. The reduced crude oil or the residue from the bottom of the column would be taken to secondary processing unit for further processing. So, that will be the secondary processing or further conversion, because the residue cannot be directly sold in the market as it may not meet the specification of a fuel oil. On the contrary, the overhead liquids collected from the atmospheric distillation column is sent to another column known as stabilizer, where LPG would be separated and then taken to the market. As we mentioned earlier, there are some process units which are primarily meant to meet the quality specifications. In the atmospheric distillation, the very first separation of crude oil into various products has happened. Now, there are few units where you are going to do some kind of process where we are trying to meet the specification of the product. Classic example for this is the improvement of octane number to meet the gasoline. Naphtha is a product from the atmospheric distillation column, but it will have a very low octane number, and as a automobile fuel you cannot send it to market. Octane number is a critical property of an automobile fuel, and this has to be minimum at 87. So, this naphtha having a low octane number of 40 to 60 is sent to a catalytic reformer unit, and finally the product octane number will be enhanced to 87 or beyond. Similarly, in isomerization process, normal paraffin components of naphtha are converted into isoparaffins which will have high octane number. So, all this octane number improvement or primarily the activities to meet the quality specifications happen in certain units. Then we move on to certain process units which are primarily to meet the environmental specifications. This is where classic example would be the desulfurization unit. From every product we have to remove the sulfur content to meet the market specification, and for each product we have a dedicated desulfurization unit is available. So, generally this is called hydro desulfurization unit or HDS. Depending on the evolving specifications of fuels, refineries need to modernize the plant by having different kind of process units. Then yet another set of process units, they are meant for converting the residue into valuable products. As I said earlier, the residue or the reduced crude oil from the atmospheric distillation column cannot be taken to market, and this is not happening in a single stage. So, this value addition for a specific stream or converting a low value product into high value product happens in multiple units. Some of the examples would be thermal cracker or a fluid catalytic cracker or hydrocracker unit. So, the residues are processed here, and different valuable products like LPG, gasoline are produced and then taken to market. So, once the product is withdrawn from the process unit, then we try to ensure that the product is exchanging heat with the crude oil, so that the crude oil is getting heated and the products are losing their temperature. If not, then we will have specific product coolers are there, which are nothing but plain heat exchanger with cooling water. Once the cooled products are withdrawn, they are continuously taken to the storage tanks. For every product we will have more than one tank. there will be some tanks which will be receiving the product from the refinery, there will be some tanks where the blending activity will be going on, and some of the tanks will be feeding to the end customer through depots or terminals. So, here in the product storage, the liquid products are stored in tanks. I think all of you would have seen different kind of tanks. So, here they are stored in either fixed roof tank or floating roof tank. Depending on the boiling range of the hydrocarbon, the vaporization loss will be identified, and based on that, if at all if lighter hydrocarbons are there like naphtha, gasoline, kerosene, diesel, they are all stored in floating roof tank. But there are certain hydrocarbons like lubricating oils, fuel oil, there is no need to store them in a floating roof tank, they can be stored in fixed roof tank. In case of hydrocarbons which are liquid under pressure, then they are stored in special vessels known as bullets and spears. The classic example of products that would be stored in bullets and spears would be LPG and propylene. And in the final stage, here we are trying to blend the products. So, as soon as the products are stored in the storage, samples are taken and the samples are sent to the quality control lab, and for each product there are some key tests. So, based on the key test, so you will be able to figure out whether the product can be taken to market or not. So, when the key tests are not meeting the specifications, then we may have to do blending. The blending can happen through multiple means. For example, kerosene and heavy naphtha can be blended with diesel, and diesel can be blended with light diesel oil. So, like that there is a scope for blending different kind of products. Then you have produced a particular fuel, but that is not meeting specifications because of low value. For example, a batch of gasoline which has got less value of octane number, what you can do is you can produce high octane gasoline and then blend them, and then finally again it is to be tested in the laboratory, and only when the laboratory gives clearance by means of the certificate of quality, then you will be able to pump it to the end customer. So, in summary, in today's episode we try to understand more about primary processing. Crude oil is a mixture of 500 plus hydrocarbon, but it cannot be, crude oil cannot be used as a fuel or lubricant, it does not serve any purpose. So, the crude oil has to be separated into various petroleum products in a refinery. The major activity to achieve this is known as primary processing. Primary processing happens in multiple steps like preheating, salt removal or desalting, heating in a furnace, distillation, and then finally blending. So, this is what we have tried to understand in today's episode. In the next episode, we will learn more about the secondary processing units. Thank you.